Hello everyone, this is Mr. Lim again. Um, from a previous recording, we have talked about arithmetic progression and the formulas for arithmetic progressions. Now we continue with geometric progressions. For geometric progression, we have common ratio. Instead of common difference, we have common ratio this time. So how to find common ratio? Common ratio is the current term divided by the previous term. And we have a different formula for Tn. Okay, we have two formula for Sn. Please apply the correct formula, accordingly. If you have a common ratio greater than 1, you have to apply this Sn. If you have a common ratio lesser than 1, apply this Sn. Okay, apart from Tn and Sn, we also have sum to infinity. This denotes sum to infinity. This is the formula. Okay, I hope you can remember the formula, although the formula sheet will be provided, but remembering the formula is very important. Okay, so without further delay, let's get started. Question 1. Given the following geometric sequence, 5, 15, 45, and so on, you need to find the 8th term and the 10th term. Okay, so I believe you know already 5 is my first term, right? Common ratio, how to find common ratio? You can consider 15 as your current term. If this is your current term, your previous term must be 5. So you can take 15 divided by 5. Or otherwise, you can take 45 divided by 15 or 135 divided by 45. You will get the same answer for common ratio. So I'll take 15 divided by 5. I got 3. Okay, wait for a moment. I got 3. I need to write that down. I got 3. Okay, so my R is equal to 3. Okay, so in this question, I need to find the 8th term. So meaning that I need to find T8. So according to formula, T8 is equal to A times with common ratio to the power of 8 minus 1, right? And then you press calculator, you should be able to get this one, 10935. Okay. Similarly, if you want to find T10, it is equal to the first term multiply with the common ratio to the power of 10 minus 1. Okay? Check if you get 98415. You should be able to get that though. All right? Next, we need to find the sum of the first 8 term. So sum of first 8 term, we have two summation formula. If you remember, we have this one and this one. So in order to find Sn for this, we need to check whether our R is greater than 1 or less than 1. So our R is 3, greater than 1. We must use this formula. Okay? So let's calculate Sn. So I want to find the sum of the first 8 terms. So I want to find S8 equal to A bracket R power 8 minus 1 over R minus 1. Okay? So if you put this in your calculator, you should get 16400. All right. If you do not have any question, let's proceed to question 2. Question 2, okay, we have first term equal to 2. We have the common ratio. What is our common ratio? 3 again, because in order to get from 2 to 6, we must times 3. 6 times 3, we get 18 and so on. What is this term? This is our T1. This is our T2. This is our T3. This is T what? So If you remember the question we discussed in arithmetic progression, we will let this as Tn because we don't know what is this, which term is this. So Tn equals 39366. All right, so I hope you still remember the formula for Tn for geometry progression. So we have A R n minus 1 equal to 39366. We move 2 to the other side, then we have divide 2. So we have 39366 divided by 2. We got 3n minus 1 equals 19683. Okay, now the problem is how to get n. So in order to get n, we have to use logarithmic rules because the n is the power. If n is not the power, then I can use the other rules. But n is the power, then I have no choice but to use the logarithmic formula. So I log the left hand side as well as I have to log the right hand side 19683. So why I want to apply logarithmic rules? Because I can move n minus 1 to the front, right? Okay. So I have n minus 1 log 3 equals log 19683. Okay. So now n minus 1 equals log 19683 over log 3. So please calculate how much you get. According to my calculation, I got 9, so my n is equal to 10. All right. So after I know that this is the 10th term, I need to calculate the sum of all terms. Again, this means T1 plus T2 plus T3 plus T4 until T10. I do want to calculate one by one. So I use the formula, the Sn formula. So in this case, R still greater than 1. So I'm going to apply the Sn formula for which is R greater than 1. Okay, so I want to find S10. My A is 2, R is 3, 10 minus 1 over R minus 1. So you should get 59048. This should be your final answer. So please check. If you don't get this as your final answer, please let me know or make appointment with any of the mathematics lecturer. Okay. If you don't have any question, we proceed to the next one. Question 3. Find the minimum number of terms that must be taken for the sequence 3, 12, 48, and so on, so the sum is more than 300. So from a previous recording, we discussed similar question, but that is for arithmetic progression. So this one, the keyword is sum is more than 300. So the same thing, we have to write Sn greater than 300. The common ratio is 4, right? We need to times 4 in order to get from 3 to 12, 12 times 4 to get 48 and so on. So in this case, R is greater than 1. So we have to apply the formula A Rn minus 1, R minus 1 greater than 300. My A is 3, my R is 4, and R minus 1 is 3 because 4 minus 1, right? Greater than 300. So I can cancel the 3. I got 4n minus 1 greater than 300. So 4n greater than 301. In this case, I have no choice. Again, I have to use log because the unknown is the power. So I have no choice. I have to use log to solve this problem. So I log the left hand side and also the right hand side. Log 301. Then I can bring n down, bring n to the front, log 4 greater than log 301. So I have n greater than log 301 over log 4. So I press calculator, log 301 divide log 4, I get 4.11. So n greater than 4.11. So what is the minimum number? The minimum is 5. Okay, so we have a few more questions in the slide. Please do as many as possible of the question, and if you do not know how to solve it, do let us know. Make appointment with us. Okay, see you. Bye bye.